Good morning, everyone. It's very nice to be here. We have been talking about the ABB from a more kind of big picture point of view, so let's dive down and look at one portion of what we are doing. My name is Helgeson. I'm heading the R&D part for Robotics. We are around 400 R&D engineers located mostly in Sweden, in Västerås, and also in Shanghai, China, and we have a large software portion in Bangalore in India. So I think to start this off, I do a lot of different presentations for different forums, which is a privilege because it's very nice to meet all of you and to get the feeling about what do you think about robotics. And my first question is really, how many of you have a robot home? Any hands up for that? I can see one. It's interesting because I met people over the years, and the trend is clearly that people come closer and closer to robots. And I went to school the other, I say, half a year ago, and I asked these kids, there were 20 kids, and said to them, and I asked the same question without thinking really, how many of you have robots home? And half of them raised their hands. They had lots of Lego robots, of course, vacuum cleaners, pool cleaners, gutter cleaners, whatever you like. But there's a lot of automation coming closer and closer to us in our everyday life. What I will talk about is, of course, the industrial part. But let's start. And I like always to ask the question, why? You know, why do we do things? Why do we need robots? Why do we need ABB robots? What can they do for us, and how can we challenge these things? And I will try to say a few words about why do we need these robots. And when we talk about the industrial portion, it's important to remember it's a rather small type of business. This year we anticipate approximately 170,000 to 180,000 robots being sold. If you compare that to the automotive industry, it's nothing. It's really nothing. You know, an automotive company not selling more than 200,000 cars is a really small company. So what are we doing? And I will come back to a few things of how we are trying to boost this, because the future looks very, very interesting. Because like I said, the things are coming closer and closer to our everyday life. So why do we do this? I like this slide. It's kind of, I will quantify more in detail, but of course we don't want to do these things. You know, who wants to have a dull job? Who wants to have a dangerous job? Who wants to have a dirty job? Would you like to buy meat from this guy here, slaughtering this pig? No, not really. So robots can help in all these areas in a very, very nice way, in a very interesting way. And that's what we are trying to develop every day with all these 400 engineers that we have in ABB. To be a little bit more precise, go a little bit more into detail, what are we really bringing to people? You know, it's not about the robot. Robot is a piece of steel or some motors and gearboxes, and you know, I'm very deep down into these things because they make life very difficult for us. But what is it really about? If you will want to use a robot, it's about quality. Number one reason why people buy robots is quality. And we are driven very much by automotive industry, and they are very, very paranoid about quality. Because cars are emotional. Everyone wants to buy their car. They want to have, you know, they don't want to have the same car as the neighbor has. And when it comes to painting cars, the quality has to be the best. But also in the 3C industry, I mean, we have some big customers. I'm sure you have a lot of computers and phones from this customer. And they are also paranoid about the quality. And if we're looking at how we polish phones with an Apple on, you can't do that with other robots than with ABB. Number two is safety. Safety is something that's very important because people don't want to do heavy lifting. They don't want to stand in a paint booth, which can be explosive, which can be dangerous. You can get a lot of fumes, all these things into you. And there are also in other areas, in foundries, plastic areas that are dangerous for people. There we send in automation. Number three is about dollar. That's productivity. Of course, people put in robots because they want to earn more money. They want to reduce dollar cost per produced unit. That's also very, very important. And another thing that comes more and more is about flexibility. Robots need to be flexible. They need to be easy to use. They need to be easy to integrate, and they need to be kind of change over time. Has to be very, very quick. And we are seeing now, originally we come from the automotive industry, which has a kind of 5 to 7 year cycle for a car model. We are going into kind of the 3C, or the electronic industry. A mobile phone has a few months. We worked with one of the big mobile phone manufacturers, and it's amazing to see how they change during the product lifetime. And that is very, very interesting, but also very, very demanding for us, extremely demanding for us. Another way to look at this is to see how is the perception of robots over the years. Because we have actually done, I mean, it was presented here earlier that we were very, very early out, 1973. We launched the first microprocessor-controlled robot, and we are very, very proud over that. And I'm actually just one of persons kind of, how do you say, nursing this heritage that we have had. But in the beginning, it was a lot of competition. People were afraid of robots. They saw them as competition. They will take away our jobs. We painted them orange because it was moving. It was seen to be something very dangerous out in the factories. Then as time went along, and especially in the 1990s, when the automotive industry really realized, wow, this is good, let's go for this. And they just pushed in a large amount of robots into the manufacturing. Today, there is no big automotive company that does not have robots in there. And people started to accept, might not have liked it, but they accepted them. You can see they were standing behind the fence, and the guys were working a little bit to the side. They kept themselves away, but you had the robots, evil, good, or whatever you could say about this. But they were there, and they were there to stay, because people realized the benefit, like I said, quality, safety, productivity, etc. Now, where we are right now, we talk about collaboration. It's a big thing. We tried to fully automate things. It was a big mistake. We just failed. You can't take, steel coming in on one side and ready products on the other side with no touching. That doesn't work, or we at least did not manage to do that. So you need to be working with the robot, and you need to be working very, very closely with this robot. That's very, very important. And what we foresee, or what I foresee for the future looking at this, is that in the next 10, 15 years or so, or even shorter, these will be colleagues, We will have them home. We will also have them in the industries. We will also kind of rely on them. And it will not be anymore about kind of the robots will work together between robots, but also with us as human beings, and they will also learn. That's a big thing. Today we talk a lot about ease of use. They are difficult to use today, but the big step will be on the software side. I'm very convinced about this. And how they learn about things and learn from mistakes, in-outflow of material, how you solve problems, interruption, and all these things. But the baseline is that they come closer and closer to our everyday life. And as I said, we are a small business, say 170,000 robots per year, but this will become much, much bigger in the future. And there will be kind of catch-up effect. And I will try to address a few of those enablers, because they are on the technology side. And, as Girish said before, we need to be a little bit paranoid, because a lot of these things will come on the software side. I just took this slide to put in a little bit. Of course, what are we competing with? It's manual labor. A lot of companies today, if you heard about Foxconn, they have hundreds of thousands of people working in their factories. I've been to a few of Foxconn's factories. It's amazing to see. These are villages. These are kind of, how you can run factories in that way with the infrastructure is, for me, really amazing. Also, still we have hard automation and you have robots in between. And what I'm trying to show here is that there is a rather big unpenetrated zone. We call it a robot zone, where we today don't use robots, but there is a huge potential to use robots. Just simply because people don't know what they cost. I can sell you a robot for 20 to 30,000 US dollars, and you can be very, very easily up and running. And there are a lot of small companies that rather do it manual or the traditional way of hard automation, not realizing that actually robots are available for them. So on one side, you have the big, big automotive guys. They have understood. They have their own people doing these things. But there is a whole kind of missionary sales side where people don't really understand that they can use robots. And we try to address these two different markets. It's very, very difficult to do that. And we have kind of our mindset. You know, I usually say to my engineers, you guys, we have fuel in our blood because we come from the car industry. And you know, a bakery guy, he doesn't think like they do at GM or Chrysler or BMW. They are totally different. And we try to learn from that. One thing I don't mention here, which is very, very important, is flexibility. Here's just the volume effect you see when you produce parts. But flexibility is very, very important. Okay, so that's a little bit about why we need robots. You know, dull, dangerous, dirty. But what is an industrial robot? I was hoping that some of you will have this guy home, but I mean, this is very interesting what they have done. If you have the opportunity to look at the Lego things, I like toys because it kind of opens up my mind. But this is interesting. And actually, it's not so far away from what we are doing. And they have a lot of nice features in there that are very similar to what we are doing in industrial robotics. I mean, I don't want to read kind of definitions, but I always, you know, let's look at the ISO definition. You know, it's an automatically controlled, reprogrammable, multi-purpose manipulator, 3 or more axes, either fixed or mobile, for use of industrial automation applications. So this is, let's think a little bit about what this means. It has to be automatically. This means that I can reprogram it, I can program it, and then I can put it in auto, and then it will run by itself. That's very important for a robot. It has to be more than 3 degrees of freedom. We normally supply 6 or more, and then you can combine them, so you can get a lot of freedom. It should be fixed or mobile, and the mobile part is very interesting, because you of course want robots to be able to move around. You can perhaps take them, put them, you know, from one place to another, and then you should be up and running again. So this is kind of the definition that we are using in the robots community. So this excludes the Lego toy. It excludes all the vacuum cleaners and lawn cutting things that are out there. But it doesn't exclude us from looking at what they are doing, because there's a lot of things coming in from that side, as I said, especially on the software side. So what do our robots look like? This is our portfolio. We can deliver to you, or you know, we are working in the range of around 1 kilo payload up to 650 kilo payload. There are robots that are up to 1,200, 1,300, but they are more lifting devices. We have on purpose chosen not to go higher up than this. You can reach between, you know, 0.5 meter up to 3.5 meters. And if you look at this picture, we have kind of 3 different areas where we work. We have the large area, which is the upper portion. See if I can show it to you. This one here. And this is typically that goes into automotive industry. This here, you see in the middle here, this is a spot welding machine. This is something that is up and running 24/7, more or less. The middle part goes into the, like I said, the general industry part. That is typical material handling. Something that weighs between, I would say, 5, 10, up to 50, 60 kilos. Picking and placing, very simple positioning from A to B, stacking something, taking it out from machines, there can be a lot of applications here. And this is typically outside automotive industry. Then we have a very, very interesting corner down here, which we call small robots. And this space is totally different from everything else. And there are lots of different competitors. And you see a lot of Japanese competitors, and nowadays also Chinese competitors going into this space. And this is typically where you see electronics industry. So if this is welding cars, typically, this will be assembling mobile phones for the future. So assembling is something that we see as what's coming and what is really very important for the future. And then I also put some of our painting machines here. And I would say when it comes to innovation, please have a look at this one here. This is a very, very special machine that we tried to we went out of the box and said, let's skip all what we had done before. Let's try to understand what the industry really needs. So if you look at that robot, you see it's like an arm. And when we put this into a paint booth, we could reduce the number of robots with half. We could totally revolutionize the way you're painting cars. So these two up on pillars working together could increase the efficiency of painting a car with up to 30–40%. Not only talking about the savings that you could also do for paint. This is the mechanical part. Of course, you need a brain. A robot has a brain, and that portion is very, very important. It's going to get even more and more important for the future. Because what we are trying to do is like creating an ecosystem. And I will come back to that, but you can find us on the web. So if you go out on the web and look for ABB Robotics, you will find us on YouTube, you will find us on other places with a lot of software that you can download and look at. And one portion is what you have inside the controller. I will come back to that a little bit later. But it's, sorry, wrong way. You see here, we can, with one controller, up to 36 axes, we have it in a multi-move configuration, which means it can work coordinated with each other. Very interesting for certain applications. To each controller, we have a little bit small computer. We call it Flex Pendant. It's like an industrial version of an iPad. So you really run your robot with an iPad. And we were the first. On this iPad, we have a joystick. So we can call it jogging the robot. So you can control the robot directions, which is very good when you're standing out in the factory. You want to set the point, you jog the robot, you click a button, you have programmed that, you go to the next point, and then you can build up your program by doing so. Of course, we have all the connectivities. I mean, today it's all about networking, putting these things together. Not only in the shop floor, but we also would like to do it on remote. We are one of the first companies in the world that put remote diagnostics and remote service into our robots. So we have one center in India, in Bangalore, that are supervising a few thousand robots all over the world. And they can kind of look in, what's the status, how are these guys doing, what have they done, can we help and support our customers in a way, and we take out a lot of learning from these things. So this is kind of a way of feeding back into us, and especially into R&D, what can we do better for the future. Just to summarize, kind of, you have seen the robot, you have seen the controller. Of course, we can do much more. You know, you can put these things together in manufacturing cells, and you can also put it together in full lines. And here, in a cell, you could perhaps talk about 1 or 2 or 3 robots. In a manufacturing line, you talk about a line with 400 or 500 robots standing next to each other. It's very, very impressive. If you ever have a chance to go to an automotive plant, please do that. And please ask them to go into the body shop, if they allow you. Normally, perhaps not, but if you're lucky, you can go in and see these things. It's very, very impressive. And I have some video clips I will show you later on. Okay? Let's talk a little bit about history, because we are very proud of the history, and I'm actually very proud that I can be working with these things, because my predecessors have done fantastic things in this area. And one thing that we are really proud of is the paint side. We were the world's first manufacturer of hydraulic paint robots. And we did this already in the 60s with the first unit sold 1969. And this is amazing. And this was a small kind of start-up thing in Norway, in a place called Bryne, south of Stavanger, in a very kind of innovative area called Halvön. And they started to paint wheelbarrows. And this is a very, very interesting and also very, very successful story. Today, I have around 70 R&D engineers working in this same place, just supporting installations worldwide when it comes to process application and paint application. The robot is the easy part in paint. To understand how the paint ends up on the car body, for example, or your furniture or chair or whatever it is very, very difficult. Especially today when you talk about nanomaterials and new types of paints that are kind of revolutionizing the way we do things. The second thing, if you go forward in time, it was mentioned here before, but we did 1973 the world's first electro-microprocessor-controlled robot. And that was really a big step. It was really a big step. There were robots that came out before, but this was the first microprocessor-controlled robot. And if you go on YouTube, you search on this, you will see there is a very interesting video clip about this Magnusson's company and how they explain how they went through this process of buying these things. And they kind of exhibited this at an exhibition in Sweden. This fellow just came there. He just kind of fully understood how he should use it from the beginning and just said, I want to have this thing. And we were not really at that time prepared to sell it. But they came to some conclusions and he started to use it and he's polishing stainless steel tubes. And these systems are up and running all, even today, I would say. One thing that is very interesting with this is that it was developed by a fellow called Björn Weissbrot. It took him 9 months to develop a robot. 9 months. When I develop a new robot model today, I can't do it in 9 months. Of course, the world has changed, requirements have changed, but we typically take 14 to 15 months. And this is something we are struggling with. They were very, very innovative and fast. And this was something we are really very proud over. There are some other very important milestones from a technical point of view. The two first I already mentioned. Another thing that we did in beginning of the 90s, 1989, we started with a modular concept. All our robots today are modular, and what does it mean? It means that they have mechanically parts that we can reuse from one model to another. It's like a Lego system. I have a drivetrain, I have a gearbox, I have a motor, I have a housing. This I can reuse from one version to another. The advantage with that is that it's already pre-tested and validated, so I can be very, very short time to market. This, together with the first dynamic modeling of the robot, and dynamic modeling is very, very important because that goes to the control of this robot, made us very successful in the beginning entering into the automotive industry. Because by dynamic modeling, you could take out a lot of cost, and especially weight of the robots. Because the early robots, they were very, very heavy, very slow, and very clumsy. With dynamic modeling, we could increase, path performance and path accuracy, as well as taking out a lot of cost from the robots in a way that no one else could do in the market. Then 1994, we implemented this fully in our open control structure, which is the S4 family. And we also introduced a kind of ease of use of a high-level programming language called Rapid that we are still using today. And then 2004, I just want to say that the tendency is, of course, more and more that robots worked coordinated together. We introduced what we call multi-move, so fully coordinated operation of 36 servo axes. And that is not easy. It's actually so difficult that we don't sell so much of these things today because people don't really understand how to use it. But I will show you here. me see here. I thought I had the... Yeah. I will show you later on kind of smaller video clip about why this is very important. So that's kind of a little bit about the history. I also, why we use robots. You have seen, dull, dangerous, dirty places. Why should you buy ABB robots? And I always ask my people, not only internally in R&D, but also when I speak to our salespeople or the front end or anyone who wants to buy a robot, why should you buy ABB? What's unique with us? And if you can't answer that question, then you have a problem, because then you don't know how to go out there, because there's a lot of things that you can buy. And I would say, from my side, we have the world's best motion control. And we can control the robot in a way that no one else can do. And what does this mean? And I mentioned this before. We have something we call True Move. Basically, what you program is what you get. We have something we call Quick Move, which kind of always ensures that you're running with full acceleration. And if you think about it, full acceleration at all point in time also puts a lot of stress on your mechanical units. So this is something that has to go hand in hand. You get what you program, always full speed, that gives you cycle time, and then we want to do it safe. And these three, True Move, Quick Move, Safe Move, is a very, very powerful combination, and something which makes ABB very unique. And I want to show you a small video about this.
Do you remember this video clip of our robots working together using our superior motion control? If we didn't impress you with that clip, how about this? What do you say? Have you ever seen an industrial robot moving with such outstanding motion control? As you can see, we've added another robot. We've also tightened up the tolerances. The distance between the cans and the pin has been reduced to an impressive 1 millimeter. And this isn't the limit of the robot path accuracy. It's the way the cans are mounted on the tray. How do we get this fantastic motion? By hours of programming? No way. Just program a path of combined straight lines and circles at normal slow programming speed. Note the three robots moving together when the programmer uses the joystick on the Teach pendant. Then run the program in automatic mode up to full speed. This is our strength. The path is speed independent. We show this by using the manual speed control. It's the same program running, no tuning needed. What you program is what you get. True Move, for the best-in-class path accuracy. Quick Move, for the shortest cycle times. And you know what? It's delivered in all our robots as standard. Superior motion control, brought to you by ABB Robotics.
And what you see here is, it's a lot of technology. But this technology enables us to do certain applications that would not be possible without this. Typically sealing, gluing, and a lot of things where you require precision. So it's not just technology. There's a lot of technology packaged here, but they enable applications that our customers buy from us. And that's very important to remember. Another thing that we have that is very unique and why people come to us is that we have a simulation and offline programming tool called Robot Studio. And this is also something you find on the web. This is free of charge for 30 days. You can download it and you can use it. I really recommend you to do that if you're interested in robots. And after 30 days, you have reduced functionality. And the reduced functionality, to be quite honest, is more than sufficient to work with. And in this package, you have access to all our robots, virtual. And they have a virtual controller inside, which is exactly the same as the one as I showed you before. So you can do what you see here in the virtual world is exactly what you get in the real world, and that is unique. And that helps a lot of planning phase, also programming phase. You can order and you can kind of check your design for collisions and other complications before the robot and the equipment has arrived. And this cuts lead time in a way which is unique. In here also we have started now we have a community. There is a Robot Studio community around the world because we have thousands of people sitting working with these tools, and they have their community chat rooms. They start to ask each other questions. We have a small ecosystem around these things, which also is quite unique. And we will build a platform, kind of like an app store on here, where you can buy and sell. At the first, you can kind of download and see things, because some people, they might need a fence, or they might need some certain scripts or whatever. So there's a lot of things that you can get out of these things. So if you check Robot Studio on the web page, you will find more information about this. It's really very interesting. Another thing that is also unique for ABB is, we are a big company, we're present everywhere. I would say we have the best service organization around the world. And it's not only about getting up and started, it's also about taking care about your robot all over its life cycle. That's very, very important. And here we have done a lot of R&D efforts, and we're trying to look at, for example, remote service, remote diagnostic, condition monitoring systems, remote control. We're working today a lot with kind of manually controlling the robots. Let's say you are sitting here in Tallinn, you have a robot out on a platform in the Atlantic somewhere, then you can control that robot via the network and such things. It's kind of very, very interesting. And service is something, we deliver to industries that are very critical. If they stop or go down, they need to be serviced very quickly. So that is one reason. So what can we do? I will just quickly go through a few things. I said one of our biggest customers is automotive industry. Of course, we build cars. It actually happens even so that we build this one. So it's a German car from the southern part of Germany, next to Munich. Very demanding customer, but very interesting customer. And I have a short video. I will show you some clips about what does it mean to build cars. And you see, we are working with flexible lines. This is an example from Spain. And they make around 1,400 vehicles per day in 3 shifts. And look at the number of parts they have. Different type of materials, different type of body shell components, but they all come in one flow. And that's very, very important. And you have a mixed flow line, of course. So this is how you start. You put the components on there, and you have your line of robots standing, welding them together. So these are typical spot welding activities. And you have the material handling coming from the side, loading into the dock. And then you go from station to station, and you do the welding of the car. And this goes on, and at the end of the day, there's you can see here this typical. And some of these factories are even kind of 3-dimensional, so the lines are going also in up and down. This is also something which is interesting, sealing. There's a lot of sealing activities in the car, and here you need very accurate motion control, because the seals are you know, depending on temperature, viscosity and everything, it's very, very difficult to apply that. And you can control the robot doing that. It's more spot welding. You can typically build a cell. Here you see you have 4 robots, but you can have up to 8 robots. So you have them in 2 different layers, 4 down, and you can have 4 hanging from the top. So you can have 8 robots working on the car at the same time, depending a little bit on the philosophy of the OEM. I think I will just continue because to give you just a feeling for what we can do more. Of course, we can pick food. Nowadays, people don't like when you are touching the food. A lot of food companies, they want to have automation coming in, handling their food, picking if it's pretzels or if it's kind of meat or whatever it is. This is very common now. Also to package things is very important. We have done an installation with Toblerone in Switzerland, so we are packaging all the Toblerones that you're eating are packed by ABB robots. Also palletizing, putting boxes on pallets is typical heavy work, and that needs to go very, very fast. So how is the future? It's a very interesting question. I mean, we really try to kind of look into the future. I mean, we come from a very, very heavy automotive industry. I mean, we come from the car industry. But what is the future? I mean, the car industry will for sure be there, and we will sell a lot of things. But in order for us to grow the business, and we are looking at different scenarios. I mean, today, as I said, we are in the hundreds of thousands robots range, which is not very much, once again. But we believe this can be 1 million. We believe very, very strongly it can be 1 million quite soon. The question is, what can we do to enable that? And we think that there's a lot of technology in there that can enable these things for the future. And I try to go through a little bit, what do I see? One thing, in order to go from 100,000 to 1 million is kind of how easy it is to use this. Ease of use is a big thing. If you would come up with the concept of how to program a robot in a simple way, I would be very, very interesting. And this is something we have tried in many different times with many different aspects, but this is going to be a game changer when it comes out. It's the same way as who would believe that you could call and use a phone with 1 button? Some 10, 15 years ago, I used to work with Helgeson in the first generation of GSM phones, and we would never have guessed that, I can promise you that. Another thing that comes is integration of sensors or intelligence from around. That's a really big thing. All the robots today, or I should say not all, but all the robots coming out in the future will have a camera. They will have eyes. Vision is something we are working very, very heavily with. They will also have feeling, force control. Why do you need that? Because you need to look at things. You need to change depending on what you see. You also need to kind of use your feeling and force control in order to assemble things. Human cooperation is very, very important, and especially the safety part. It has to be safe to work close to a robot. And safety is something we are working very, very much with. It's very important. And then you have these things like footprint weight, service, design for service, I mentioned before, is very important. Then we have the whole, even though we know that it's not something people earn money on, but the environmental impact and energy cost is very important. And a lot of companies are very, they take a lot of care about their image. So we get a lot of questions. Our robots are green, and we put a lot of effort in making them green. You saw that we have the true move, the quick move, and the safe move. We are planning also in the future to have a green move type. So we can optimize. If the customer says, I don't want to optimize on cycle time and performance, but I want to optimize on energy consumption, we can do that. And that will come in the future more and more. Also, what we are seeing starting coming is kind of the open source components. That's very interesting. There's a huge community of people building things out there, and they're putting them out on the web for free. A lot of these things that we are selling today, you can find on internet if you're clever. And we can't stop this. You just have to accept and live with it. And motion control, I mean, when I started, there were almost no courses or students for robotics. Today, almost every university have robotics. All the robotics students have made a path planner in C#, C++, or whatever. And those guys are coming out and they are starting up their companies. Another thing I just put here, kind of because we discuss it quite a lot now, is of course cloud. Everything will go into the cloud, including our controller and things. And what does that mean for us? That's kind of difficult to say, but it's a very, very interesting prospect. Another thing that we see coming is, of course, I mentioned Foxconn. This is a picture from one of the 3C manufacturers in China. And you see that there are a lot of people sitting doing manual work. And we have kind of tried to look at this, and we have a kind of finding a solution. I mean, if, as I said, automotive industry, welding was where we came from, now the future will lie in assembly. If we can have robots putting things together, if it's mobile phones or other type of electronics or watches or these things, then we will be successful to reach this 1 million robots per year. And I don't know if you heard or read about the CEO of Foxconn. He went out, I think, last year and said that they have an ambition to put in a lot of robots into their factories for the future. And he's kind of up in the range of hundreds of thousands to millions of robots in order, because they realize we cannot continue like this with all these people. And they will happen a lot here. And we have kind of taken that challenge on. I don't know if you have seen, but we have a technology study type of robot called Frida, which is out available. You also find on YouTube, out on the web. It's kind of an intrinsic safe, which is very, very important. Intrinsic safes means that it's safe by nature. And it can work next to a human being. It has 2 arms with 7 degrees of freedom per arm, so it's 14 axes. And like I said before, to control this, you need to have world-class motion control, and that's what we have in ABB. And it's lightweight. You can take it up. You see it's a handle here. The idea is that you can lift it up. You can, you know, today you have a station with a person. Tomorrow you can take this robot and put it in that station with the robot. And the idea is that the robot and the human should work together. We are not there to, you know, of course we want to take, you know, the long lines of people sitting doing the assembly will change, but we don't want to take away the people. There needs to be a mixture of robots and people in there. And that is very, very important, because we don't believe in fully automating these things. Lightweight is another thing here. Not only intrinsic safe, but it has to be lightweight. And lightweight, it's not only that it's the weight of the manipulator itself, it's also the way how we see things in relationship of how much you can lift in comparison to how much you weigh. That is lightweight. So robot assembly is definitely something coming for the future. And I have a small video I would like to show you how we can do this. So this is our Frida robot. And here you can see, I cannot explain everything, unfortunately, but this is typically how this robot works. You see the 2 arms. It works very similar to a human being. This is much more complex than to spot weld the car, if you thought about the pictures I showed you from before. There are many more steps, and there is a much more complex thing when you do assembly about in and outflow of components and parts. And that needs to be solved. And this robot needs also to be very, very flexible and reprogrammable. So here we have, it's not a robot anymore, it's a kind of little system, because it has 2 arms with each 7 axes, but it also has 2 hands. We call them grippers, and each hand has a camera built into it. So they also have eyes. And we also kind of have the feeling, because we can measure the currents of the motor. So we have some kind of very simple version of force control in there. So this little fellow, he has eyes, he has feelings, and he has 2 arms to work with. And it's safe. We did the presentation where one of our R&D guys, he even put his head in there. I wouldn't do that, but he did that, and actually everything was okay. Also interesting to know is that next year there will be a whole bunch of new rules and regulations here in Europe for what safety means in an industrial environment. And a lot of people that are saying that they have a safe robot today, they will not have a safe robot tomorrow. Because people are working a lot with safety. By that, I would like to end my presentation. I don't know if there are any questions.
Thank you for this very interesting presentation. Just to give you an example how much of people are interested of robotics, there are also here in this university is a special dedicated club for robotics. So it's most certainly very interesting.
That's nice to hear.
Okay, we have a few questions also. And the first one would be, how do you learn about the needs of your clients and find new solutions for different production processes?
I mean, we try to be very market-driven. I mean, that's one of our kind of key cornerstones. The problem is with market-driven, you know, it is a little bit contradiction to innovation. So we try to separate those two processes. But we have a lot of early adopter customers. So when we develop things and we have ideas, we have some customers that we are very close with that we send out robots for them to try. And we get very good feedback from these companies. And we do that worldwide. Because the demands in China are different from the demands in the US, and they are different from the demands in Europe. It's very, very interesting how we can create a common platform, but on top of it, we can customize the different needs that they have in the different markets. But this is very, very tricky to capture. And I like to come back to what Girish talked about. We can capture a portion which is in the industrial space, but we cannot capture these small software companies around in the world, and there we need other means, and I think it's a very good way to work with a kind of venture approach. But that's how we try to do this.
Okay, thank you. Next question would be, why do you think people are afraid of advanced technologies, robots? In your opinion, is this fear reasonable?
I think normally people are afraid of things they don't know and understand. I mean, it's the same with me. And once you come a little bit deeper and closer into this, people kind of start to accept these things. And if you think about the slide I show you with the 4 different eras, I mean, we are really at the stage where people like to collaborate with the robots. They have accepted that the robots will be there, and it will be there for the future. And if you look at how much time and money and effort, for example, Japan puts into this, it's amazing. And they have just kind of trying to address a lot of issues, not only on the industrial side, but also outside, kind of on the social side of the aging and demographics. They just realize we have to put some kind of automation in there, and it has to be very close to humans. So we work a lot with kind of educating people, working with young people, a new generation of people. And I must say that there is a big change, you know, when you see the people who are brought up in the kind of internet era. I mean, they have no problems to use our equipment. They are not afraid. They take them and they start to use them very, very quickly. It's the people like me who are so old that kind of, we have a classical background.
Okay. Then let's take one last question. Do you know, are the future robots going to be made out of steel or something else? For example, composite
That's a very good question. I mean, there are, of course, a few things I can't talk about, but that touches a very interesting area. Of course, I mean, you have to realize steel is a very, very good material from many perspectives. It's cheap, but also has a lot of nice properties. But of course, the future will be different. Of course, there will be new materials coming into robots. And we are looking at a lot of composites. Now, if you look at it, without going into robotics, I can give you an example from the car industry. If you look at what Audi have done, people were laughing a number of years ago, and it's not so long time ago when Audi started to do composite in their cars. They started with aluminum, light materials, and then they started with composites. Nowadays, if you buy an A6, the new release, it has a lot of lightweight material and composite, and it is commercially viable today. So we are working, and with composite and materials, it's very nice because you can control the properties of the material in a way that is very, very attractive. And you can then optimize for cost, or you can optimize for performance or speed. So the answer is clearly yes, it will come.
Okay. Thank you very much for your interactive presentation.
Thank you very much.